Hello PCH students. I wanted to give you guys more examples on proving identities since we ran short on time in class today on Monday. And so in this video we're going to look at a few more examples of proving identities. Let's start with example 3. So we did 2 examples in class and here is example 3. We're going to prove this: cosine of x minus cosine x sine squared x equals cosine cube x. This cosine cube x is the same as if I had written cosine x in parentheses and then cubed the whole thing. Okay? So the first thing here is you choose a side to work on. So I'm going to work on the left-hand side by factoring out a cosine x. So I have 1 minus sine squared x. Then I'm going to use the Pythagorean identity, which tells you that this equals to cosine squared x. And so the Pythagorean identity gives us that. So this becomes cosine cube x, and now the two sides match. And so we are done. Okay. The next example that I want to do is example 4. And here we have 1 plus sine x over cosine x equals secant x plus tangent x. So we have to pick a side. So I'm going to show you 2 methods. First, let's work on the left-hand side. Well, here we have 2 terms in the numerator and 1 term in the denominator. So you can write it as 2 different fractions. 1 over cosine x using the reciprocal identity gives us secant x. Sine x over cosine x using the quotient identity gives us tangent x, and here we have it. But we can actually do an alternate way, and that is to mess with this side. So one strategy for proving identities is to write everything in terms of sine and cosine. So secant x is going to be 1 over cosine x, and tangent x is going to be sine x over cosine x. Well, 1 over, and then you see that these two have common denominators, so you can add them together, and then you get what was on the other side originally. So you could have worked with either side in this problem. One, the left-hand side uses the idea of writing them as separate fractions. The other side, the right-hand side, uses the strategy of writing everything in terms of sine and cosine. Okay, let's go on to the next slide. Okay, let's go on. All right, here is the next slide. So we now have number 5. So example 5. Okay. Example 5 is cosine x over 1 plus sine x plus 1 plus sine x over cosine x equals to 2 secant x. So in general, you want to choose to work with the side that is more complicated. So here clearly the left-hand side is more complicated. One important strategy is when you have 2 fractions, sometimes it helps to combine them into one fraction by doing common denominators. So the left-hand side is missing a cosine x and the right-hand side is missing a 1 plus sine x. So we're going to put that in parentheses. We will get rid of this. Oh, we will erase this line right here. Where is it? Right here. We're going to erase that line. Nope, it's not erasing. Okay. Anyway, over cosine x. Well, this side is missing the 1 plus sine x over 1 plus sine x. Okay? Alright, so now the numerator of this first term becomes cosine squared x. and you have this as the denominator. The other side is 1 plus 2 sine x plus sine squared x all over cosine x parentheses 1 plus sine x. As you can see, the two fractions now have common denominators, so let's add them together going across the top. I have cosine squared x plus 1 plus 2 sine x plus sine squared x all over 1 plus sine x times cosine x. Alright, so now, as you can see, we have this and this giving us 1 using the Pythagorean identity. Okay, so that's a 1. Okay, so what's left is 1 plus 2 sine x over 1 plus sine x cosine x, which then gives us 2 parentheses, or 2 parentheses 1 plus sine x over 1 plus sine x cosine x. Cancel, cancel. We have 2 over cosine x, which is 2 secant x. And now we have proven the identity. Next example, example 6. We have sine x over 1 plus cosine x equals 1 minus cosine x over sine x. Now keep in mind that we cannot cross multiply here. If we cross multiplied here, we would be assuming that the equations are equal. But we're trying to prove that they're equal, so we must work with each side individually. Here the two sides look kind of similarly complicated, so we can do either side. So let us choose the left-hand side. Here is a strategy that is useful sometimes. We multiply the numerator and the denominator by the conjugate of the denominator. So the denominator here is 1 plus cosine x. The conjugate would be 1 minus cosine x. So now we multiply, but we do not distribute the numerator. Keep them as a product of sine x times 1 minus cosine x. But the denominator is a difference of squares. And if you remember from algebra class, doing conjugates often gives us, or always gives us, a difference of squares. And in this case, the difference of squares is very, very useful because now we can apply the Pythagorean identity. 1 minus cosine squared x is sine squared x. Then we have sine x canceling with one of the sine x's on the bottom, giving us 1 minus cosine x in the numerator and sine x in the denominator, and that matches the right-hand side, and we are done. Next example. Example 7. Tan x minus sine of negative x over 1 plus cosine x equals tangent x. The left-hand side here clearly looks more complex, so we will work with the left-hand side. Now I chose this example because this illustrates the use of the negative angle identity. Sine of negative x is the same as negative sine x. And then all over 1 plus cosine x. So the numerator is now tan x plus sine x all over 1 plus cosine x. Now at this point, there are various ways that we can go. But right now I'm going to show you the strategy of converting everything in terms of sine and cosine. So tangent becomes sine x over cosine x. And then you also have plus sine x in the numerator, all over 1 plus cosine x. Then I'm going to use common denominators to combine the numerator. The two fractions or the two terms that are in the numerator right now, we are going to combine them using common denominators. So what we have is sine x plus sine x cosine x over cosine x all over 1 plus cosine x. Now right now it looks really messy, but it is about to clean up pretty nicely. The numerator of the numerator right now, I can factor out a sine x, leaving me with 1 plus cosine x all over, and then I can rewrite this, join the cosine x with the 1 plus cosine x. And so these are just simple fraction rules. The 1 plus cosine and the 1 plus cosine go bye-bye. Then you're left with sine x over cosine x, which is tangent x, and voila! You have the same expression as the right-hand side. Next example. This is the last example we are going to do with proving identities in this video. This is example 8. 1 over 1 plus cosine x plus 1 over 1 minus cosine x equals 2 plus 2 cotangent squared x. Now this 8th example is a special one because I'm going to show you a strategy that we did not use in any of the first 7 examples. Well, first we're going to adjust the left-hand side by doing common denominators. So the first term here is missing a 1 minus cosine x. So we have this. Ooh, I should write this in pink. Okay. The second term is missing a 1 plus cosine x. I am going to erase this line right here. Okay, how come these lines are not erasing? Okay, forget it. All right. Sorry for this vertical line that's in the way. Okay, so now I can combine it into one single fraction, and if I add across the numerator, I get 2. And the denominator is 1 plus cosine x times 1 minus cosine x, which will give you a difference of squares. So you now have 2 over 1 minus cosine squared x, which is going to be 2 over sine squared x using the Pythagorean identity. Now, look at this, 2 over sine squared x. It looks nothing like the other side. So for the first time in this video, we are now going to stop working with the left-hand side and now begin to work on the right-hand side. And so we are now working on the right-hand side. Remember, the two sides can never interact, but it is okay to pause, stop working on one side, and start working on the other side, as long as you're not doing anything to both sides at the same time. Okay, so the left-hand side, the right-hand side is 2 plus cotangent squared x. So we're going to first factor out a 2, giving us 2 parentheses 1 plus cotangent squared x. Okay, and one of the Pythagorean identities tells us that 1 plus cotangent squared x is cosecant squared x. Sorry for the delay here. Cosecant squared x. That's one of the Pythagorean identities. And cosecant squared x is the same as 1 over sine squared x. And voila! the two sides are now the same. Notice that you can work on the two sides at different times as long as at the end what you have on the left matches with what you have on the right. All right, so these examples will help you do trig worksheet number 2, problem number 3.